All right, so for this video, I'm just going to go through a bunch of problems pretty quickly. The first one that I'm going to go through is page 1, question 1. So the way that I will show you, it will go page first and then the question number on the page. And then I will write the question. So it is the 4th root of 5 cubed. And it says to rewrite this in rational form. So in rational form, we need to rewrite this as some number, our base, raised to a power that is a fraction with our numerator and our denominator. So we know that we are going to rewrite this as a power that is a fraction, a fractional power. That's what it means by rational form. So the number inside of our radical, called our radicand, that is our base. So our base is 5. Now it's being raised to a fraction power. Remember, back when we learned this, I said it is our power over our index. So the power, whatever it's being raised to. So in this case, it's being raised to the 3rd power. So that is our numerator. And whatever our index is, whatever root we're taking, that is our denominator. So this is equal to 5 to the 3/4 power. All right, the next question I'm going to go over is question 1.5, which is 25 raised to the 3/2 power. All right, this is asking you to evaluate. So when we're evaluating, I think it's easier to do reverse what we did in our first problem. So we're going to rewrite it back as a radical because I think it'll be easier for us to solve in that form. So our base is what our radicand was, what we were taking the root of, so that would be 25. It is power over index, so we know that this is being raised to the 3rd power, and our index is 2, so we don't have to write it because when it's not there, it's understood to be the square root, but we can write it. So now we can look at this and say, okay, now it makes a little bit more sense. What we're doing first is taking the square root. So the square root of 25 is 5, and now we're still left with this 5 cubed, so it is equal to 125. So that's why it's important to be able to write these in different forms. One, sometimes it's easier for us to answer questions like it was here, and sometimes it's better for us to rewrite it as this form than it is to leave it as radical as well. All right, the next question I'm going to go over is question 13 on page 1. I just want to go through these rules real quick. Remember, anything raised to 0 power is equal to 1. If we have something raised to negative power, then we need to take its reciprocal to make it positive. When we are multiplying, so as long as it's the same base and not different bases, as long as it's the same base, we go ahead and add our powers. So this is then equal a to the 5th. When we are dividing, let me change this to a 3. When we're dividing, we would subtract our power. So this would then be equal to a to the 3 minus 1, which is then equal to a squared. And power to a power, we multiply. So these are all the rules that we've learned before. Anything raised to 0 power is 1. When we have a negative power, if we want to make it positive, we take its reciprocal. So if it's in the numerator, it drops the denominator, or if it's in the denominator, so if it's 1 over a to the negative 1, it will then be equal to a to the 1st power. It moves to our numerator. Multiply, we add. Divide, we subtract. And power to a power, we multiply. So now we're just going to go ahead and solve this. So we have n to the 0 power. So that means it's equal to 1. So we can just cross it out and just rewrite 1 there, or just know that that's equal to 1. So the first thing I'm going to do next is distribute this power 2 to everything. Because remember, when it's in parentheses, everything needs to be squared. So this then changes to m over 3 squared, which is 9. And then power to a power, we multiply. So it'll be m to the 4th and n to the 4th. And then, remember, anything written, if it doesn't have a power there, it's understood to be 1. Well, we have 1 power here and 4, so I can subtract 1 from there and know that there's 3 left over. So our final answer is 1. But that's what happens when we cancel out that m, over 9m cubed n to the 4th. All right, the next one is 2.19. So remember, when we're multiplying scientific notation, we need to multiply our likes with our likes. So what I mean by that is we'll multiply our coefficients, so the numbers, and then we will go ahead and multiply our numbers that are being raised to the power, so our base 10s. So when we multiply 2 times 7, we get 14. And then when it's 10 squared times 10 to the negative 1st, remember, we will add those powers, so it becomes 10 to the 1st, or just 10. However, in scientific notation, this number can only be less than or greater than or equal to 1, or less than or equal to 9. So this number cannot be greater than 9, and it cannot be less than 1. So that means we need to rewrite this. So we know we have a decimal here, so we need to move it 1 space over to the left, so that way it is written with a number that is between 1 and 9, including 1 and 9, in front of our decimal. So it's 1.4. And remember what I was saying in class is anytime we make this number smaller, we need to make this number larger. We need to offset it. So since 14 is moving to 1.4 and it's moving smaller, we need to add however many decimal places we move, so it's times 10 squared. Had this been made smaller, this one would have had to have been made, if this was made larger, this one would have had to have been smaller, so we would subtract however many decimal places we move. All right, I put the next two problems next to each other. So for this one, we want to write it in scientific notation. So remember, that means that we need to have our first digit in front of our ones be between 1 and 9. So we need to move this decimal place because this is less than 1. So we're moving it twice. So now we're moving it so it's 7.3. And when we make this number larger, we need to go ahead and make the other number smaller. So it will be times 10 to the negative 2 power. All right, so that's one of the ways you can remember. Every number is understood to be multiplied by 10 to the 0 because this is equal to 1. So the number that we get in the beginning, we can think that it's being multiplied by 10 to the 0. So since we're making this number larger, we need to make our 10 number smaller. If we want to make this in scientific notation, since what we can do now is we know that we're moving it 10 times 10 to the 4th, so we need to make this number larger because 10 to the 4th is greater than 10. So we're moving this decimal place 4 spaces to the right in order to make it larger. So this will then be 2, and it'll be 1, 2, 3, 4. So this is telling me it's 20,000. All right, that is it for this first section, this first page. I'm just going to keep going through all of them like this. If you have any questions, just please message me. All right, so for the next one, I just copied all the questions, and I just want to go over them real quick. Remember, our natural numbers, it's all of our whole numbers, including zeros. So it's 1, 0, 1, 2, 3, and so on. Only positive whole numbers and 0. Our integers are all of our naturals, so we know we're going to include 0, 1, 2, 3. But now we also include our negative numbers, so we will have negative 2, negative 1, so on. So it's all of our positive and all of our negative. Our integers are any number that we can express in a fraction, so we can rewrite it as a fraction, a over b. And if it is a fraction or a decimal, it ends or terminates, and it's also non-repeating. It is repeating. So we can either have a decimal, like I'll just give you examples here. So 0.3 repeating, that would then mean it's rational. 0.25, that means it ends, it stops there, so it's rational. Irrational, there is no symbol for it. But the way that you will see it in here is it will say it is not rational. The decimals never end, and they are non-repeating. So pi, we know that decimal never ends. It's non-repeating. Any square root that's not a perfect square, so square root of 2, square root of 3, they're non-repeating, never ending, and so on. And it also can't be written as a fraction, so it's irrational. And then real numbers are anything that can be written on a number line. So it's any real number, any number that we're working with right now. So let's just go through these. Since this says z positive, that means it has to be a positive integer. Negative 2 is not positive, so it's false. Is 4 rational? Yes, we can rewrite 4 as 4 over 1, so it is a fraction. So yes, it is true. 4.2 is not irrational. That's false because since it ends, that means it has to be rational, so it is false. It is rational. Square root of 4 is equal to 2. 2 is a positive whole number, so that is natural, yes. 2/3 is rational. That is true because it can be written as a fraction. 2.2 is an integer. That is false because 2.2 is not a whole number. An integer has to be a whole number. Any number that's not complex is going to be real, so that is going to be true. This one, 3 divided by 0.03, is equal to 100, and since 100 is a positive whole number, it is an integer, so that one will be true as well. So sometimes they won't look like they will work, like the square root of 4 or 3 over 0.3, but when you solve for what the number is actually equal to, it does in fact work. All right, the next problems are 3.2. I'm going to go over these two because these are two different examples. Remember, anytime it's a real, our answer is going to be a straight line because it includes all of our numbers. And anytime it is an integer or natural number, it is going to have to be points because it only includes our whole numbers. So for A, we're looking for numbers that are between 3 and 7 equal to 3, and they're integers. So that's the main thing here. So we're going to go 3, 4, 5, 6, and 7. So since it's greater than or equal to 3, we would have to put a closed circle because it's equal to it, and it's less than 7. So you can either put an open circle there And then now, since it's an integer, we're only coloring in the whole numbers. Or if you wanted to, you can leave it like this, and I would still give you full credit because since it's less than 7, we're not including it, and we can't include any of these decimals in here anyway, so you can do it like this. Or if you write this open circle, we're going to 7 but not including it, I would accept that as well. For B, it is real numbers, so we can go ahead and draw our number line, and it will be from -4 to 7. And then when it's a real number, we just need to look at our symbol. So since it's equal to, it's going to be a closed circle at -4. Since it's equal to, it's closed circle at 7. And then we're just going to go ahead and draw a line connecting them. So real numbers include every single number in between. So it's including this -0.5. It is including this pi that's in here. So it's including all the numbers, which is why we need to draw the line. When it's an integer, it's only the whole numbers. All right, so for this problem, the first thing you have to do is realize that your universe is equal to all the numbers that are z positive that are less than or equal to 12. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And when we go through this, it says that A is equal to 9 through 12, and we want to find a complement. So we're looking for the complement of A. Well, when we say the complement, it means it's part of our universe, but not part of the set. So since A is 9, 10, 11, 12, that means that A complement would have to be everything else. So it's 1, 2, 3, 4, 5, 6, 7, and 8, because all of these numbers are part of our universe, but not part of A. All right, so this one is page 5, question 11. So the first thing you should do when you're getting these questions is you should draw your Venn diagram, right? And then we're going to draw our sets. So our sets that we're going to label is people that play the bass and people that play the guitar. When you see it's percents like this, you can just forget about the percents and just write 56 or 71, 18, because it could also represent 56 out of 100 people. So you can just think of it as a whole number, and then when you're giving your answer at the end, you can just write percent at the end. So it says, we want to know how many people play both bass and guitar. Well, 56% of people play bass, 71% of people play guitar, and 18% play neither. So what we can do is first fill in this. There's 18% or 18 people that don't play either of those. So there's 18 out of our universe that don't play either. So now we need to figure out, well, how many people at least play the guitar or bass? So we know that when we're dealing with percentages, the most we can have, or what everything needs to add up to, is 100%. So we'll subtract the 18% of people that don't play either. So that means there's a 82% of people who are playing bass, guitar, or both. So they tell us that 56% play bass and that 71% play guitar. So if we add these two together, we would get 127% or 127 people. But that doesn't make sense though. And also, if you think about it, some of these people will play both the bass and guitar. So we need to figure out how many people are playing both. So what we do is we add them together and we take this 127 and we subtract what's left in our universe, because we know that there's 82 people left in total, 82%. And those 82% can play bass, guitar, or both. So when we subtract this from the total that we get when we add them together, which is then 45, that tells us how many percent of the people play both. So 45 or 45% of the people play both bass and guitar. And if there's 56% that play bass, that means there's 11 that play just bass. And if there's 71 that play guitar, that means 71 minus 45 is then equal to 26. So that means there's 26 people, or 26% that play just guitar. And the way that we can check our work is if we add all of these up. That's why it's good, even though we're only asked to find a percentage that play both, if we add up all of these, then we should get what the total number is. And since we're dealing with percentages, our total percent should be 100. So 11 plus 45 plus 26 plus 18. So this will then give me 6, 12, so 20, 3, 7, 9, 10. So it's 100. So I know I did this correct. So the amount of people that play both is where they're shared in both circles. So it's 45% of the people play both bass and guitar. All right, the next one will be from page 6, number 2. So for this one, we have the square root of 5 cubed that we need to go ahead and multiply. So we know that this means the square root of 5 times the square root of 5 times the square root of 5. So these two square root of 5s is equal to 5. We still have this 1 root 5 left over, so it's 5 root 5. So now it's 7 root 5 minus 5 root 5. And then here, the square root of 5 squared. Well, whenever our power matches our index, we know that they cancel each other out, so it's equal to 5. So then it's plus 5. So in order for us to add or subtract any radicals, we must simplify them first. and then we look and see, are they the same? They have to have the same radicand, so that means the number inside of the radical, and the same index, which these two do. So then we add or subtract the numbers out front. So 7 minus 5 is equal to 2. So this is 2 times the square root of 5 plus 5. There's nothing else that we can reduce. There's nothing else that we can simplify, and that is your final answer. All right, both of these problems are also from page 6, so I'm just going to go ahead and do them together. So when we're asked to simplify our radicals, remember when it's a fraction, if we can't take the square root of each, then we should go ahead and rewrite them under the same radical so we can see, can we simplify? Well, 3 goes into 48 6 times, so then we're left with the square root of 1 over 16. And this was a mistake that a lot of you guys made in the last test that you took. The square root of 1 over top of the square root of 16, we can now separate them. Well, the square root of 1 is equal to 1, and the square root of 16 is equal to 4. So this simplifies to 1/4. It is not, as someone was asking in class, it is not plus or minus because this is not an equation. When we're just simplifying radicals, they simplify to either positive or negative, depending on if it's a positive sign out front or if there was a negative out front. The reason why we are doing plus or minus for the questions that we were just solving is when it's x squared is equal to 4, the original question posed is what number squared is equal to 4? And since there's two numbers, a positive 2 squared and a negative 2 squared that are equal to 4, when we use the square root to solve, that generates two answers, plus or minus. When it's just written like this and no equation, it is not plus or minus. All right, so now to do the next one, when we're trying to simplify the radical, we need to see, are there any perfect squares that we can take out? Because we can't take the square root of 18. However, within 18, we can rewrite it as 9 times 2. And we know that we can take the square root of 9. That is equal to 3. So this one can be rewritten as 3 times the square root of 2. So when we're asked to simplify our radicals, we're trying to see, are there any perfect squares that we can take out? All right, this next one, so we're seeing we can't take the square root of 147, so we need to see, are there any perfect squares that we can take out? Now, if you're not sure, write down all of your perfect squares. So don't write 1, but write 4, 9, 16, 25, 36, 49, 64, 81, etc. Write them all down and see, can either of these divide into them? Well, the one I can divide into it is 49. So 49 goes into 147 3 times. And the square root of 49 is 7, so we can rewrite this as 7 times the square root of 3. So when we're simplifying, we're trying to figure out what perfect square is embedded within this number that we can reduce. All right, now this next one, we're asked to multiply these. So it might just say simplify, but it might say multiply. But when you're asked to multiply these, we need to FOIL. So we'll do our first times our first. And remember, when we're multiplying radicals, we need to multiply our likes. So the number's out front, so 2 times 2 is 4, and then we need to multiply our radicals. Well, the square root of 3 times the square root of 3 is equal to 3, so this is equal to 4 times 3, which is 12. And then we will do our outer, so this would then be 2 times -1, so that's equal to -2. And remember, as long as if our radicals have the same index, we can multiply what's on the inside. Unlike adding, they don't have to be identical. So since these two indices or indexes are 2, we can multiply them. So 3 times 2 is 6, so it's -2 times the square root of 6. Then we'll do our inner, so that's 2 times 1, so plus 2. Once again, 2 times 3 is equal to 6, so then it's be a square root of 6. And now we have square root of 2 times negative square root of 2, so that will give me a -1. And root 2 times root 2 is equal to 2, so it's -1 times 2. So now we have 12. This -2 times the square root of 6 plus 2 times the square root of 6 will cancel, and then -1 times 2 is -2. 12 minus 2 is equal to 10, so this reduces to just 10. All right, these two are both from the same page and are the same thing. We're writing them, combining fractions, adding or subtracting fractions, so I'm just going to go ahead and do these together. Remember, when we're trying to add or subtract fractions, we need common denominators. So this one has a denominator of x, and although nothing is written there, it's understood to be over top of 1. So that means this denominator of 7 that has a denominator of 1 needs a denominator of x, so we're going to multiply it by x over x. So this then gives me 7x over x minus 4 over x. And now since they're the same, we can go ahead and combine our numerator. Well, they're not like terms, so it's just simply 7x minus 4 over top of x, and that would be your final answer. You cannot reduce or simplify this x over x because this 4 does not have 1. All right, then for here, we're looking, our denominators are 2, 4, and 6, so that means the least common denominator, least common multiple, will be 6. So in order to get this 2 to a 6, we need to multiply it by 3 over 3. In order to get I was not thinking there. Our least common denominator, least common multiple will be 12. I was just kind of rushing through that. So now it's going to be equal to 12. So this will then need to be multiplied by 6 over 6. This one, let me rewrite this so I have more space. So it'll be n over 2 minus n over 4 plus n over 6. So this one will need to be multiplied by 6 over 6. This one will need to be multiplied by 3 over 3. And this one will need to be multiplied by 2 over 2. So it gives me 6n over 12 minus 3n over 12 plus 2n over 12. And now since these are all the same, we can go ahead and combine our numerator. So 6n minus 3n is going to give me 3n, and 3n plus 2n will give me 5n over 12. And that will be your final answer. All right, the next one says to simplify this as one fraction. So since there's multiple terms, what we have to do is factor. So we're going to factor. Remember, when you're simplifying fractions with multiple terms, you have to factor first. If it was already factored for you, you just cancel out your factors. Well, here we have a GCF of x, so we're left with 3 minus x. And here we have a GCF of 3, so we're left with 3 times 3 minus x. Well, since this 3 minus x is exactly the same, we can cancel those out, and now we're just left with x over 3. So this simplifies to just simply x over 3. All right, the next one, we're simplifying this fraction. So now, once again, when there's multiple, we need to factor. Well, this one's not as easy as just factoring our GCF, so we're going to use our x method. So 6 times negative 3 gives me negative 18, and 7, this drops here. Numbers that multiply to negative 18 and have a difference of 7 are 9 and negative 2. Now, this is the one thing that you guys forgot to do in your test when we did this, is you all, or not all, but most of you, or a lot of you, forgot to divide by that a. Most of the time, it's just being divided by 1 because it's just simply x squared, but when it's something other than 1, we need to divide by our a and then reduce. Well, 9 over 6 reduces to 3 over 2. And then 2 over 6 reduces to negative 1 over 3. So this numerator factors out to, remember, we started from the bottom, now we're here, so it factors out to 2x plus 3. And then we start from the bottom, now we're here, so then it's 3x minus 1. Now we're going to go ahead and factor the denominator. So this will give me 2 times 6, so that gives me 12. The 7 drops to the middle again, so numbers that multiply to 12 and add up to 7 are 3 and 4. Once again, do not forget to divide by that a or that 2. This reduces to 2 over 1. So this then factors, started from the bottom, now we're here, so it's 2x. So then it's 2x plus 3, and then the other one factors to x plus 2. So since both of these have a 2x plus 3, they can cancel, so it's 3x minus 1 over x plus 2, and that will be your final answer. All right, this next one, right, as a single fraction. So that means, once again, we need to have common denominators. Well, this one has x minus 3, and this one has x plus 2. So neither of them are the same. And since it's not just numbers, we need to multiply by the opposite denominator. So this one will be multiplied by x plus 2 over x plus 2. And this one will be multiplied by x minus 3 over x minus 3 so that we can get the exact same denominator. So we're going to distribute this x in, so we get x squared plus 2x over top of x plus 2 times x minus 3, and then we're going to distribute a 5 in, so plus 5x minus 15 over top of x plus 2 times x minus 3. And now, since these are exactly the same, our denominator, we can go ahead and add or combine our numerator. So we have only an x squared, so there's no other x squared. Since they're adding, and we have 2x plus 5x, so that gives me plus 7x, and then there's only this minus 15. And now it's over top of x plus 2 times x minus 3. Remember, you do not have to multiply your denominator in, but if you have factors in your numerator, you must multiply them in. So then we look and see, can this factor, so we can see if we can reduce it. It does not factor because there's no numbers that multiply to negative 15 and have a difference of 7. There's only factors of 15 are 1 and 15 and 3 and 5. None of them have a difference of 7, so this is it. This is your final answer. All right, so for this one, remember, we're using Pascal's triangle. Pascal's triangle is 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. You will not be given this on the test, and you will have to create this. What we do, it's really easy if you remember, is we just go ahead and we add the numbers that are to the top right and top left to it to generate the numbers in the middle. And since this is a power of 4, we know we need to go to the 4th row. So then we follow our formula, and remember, you don't have to write this, but we write it as if it's a plus b raised to the 4th power. And the numbers that we know we write first are the coefficients of that row for Pascal's triangle. So here's our row 4. So we will write 1, Let me write it underneath of it so I know I definitely have space. So it'll be 1, 4, 6, 4, and 1. And then we will start with our a. And remember, it gets raised to the same power that we have. So it's a to the fourth, a cubed, a squared, a to the first, and a to the 0. B starts with 0, and then we add 1 every single time. So it's b to the first, b squared, b cubed, and b to the fourth. And these are all positive in between. This negative sign is just going to work itself in as we go ahead and do this. We can cross out our b to the 0 and a to the 0 because we know that that's equal to 1. And then after we do this, we say, all right, well, a is our first term, so that means a is actually equal to 2x. So wherever I see a, I'm going to replace it with 2x. And b is actually equal to negative 1 because that's our second term. So wherever I see b, I'm going to replace it with negative 1. All right, so now I'll go ahead. It will be 2x to the fourth power times 1 plus 4 times 2x cubed times negative 1 to the first plus 6 times 2x squared times negative 1 squared plus 4 times 2x times negative 1 cubed plus negative 1 to the fourth power. So I'm just going to go ahead and write this. 2 to the fourth power will give me 16. Well, 16 times 1 is 16x to the fourth power. 2 cubed is 8. Negative 1 to the first is negative 1 still. This is 4. 4 times 8 times negative 1 is minus 32x cubed because we have our x to the third power. And this is what I was saying. The negative sign is just going to naturally work itself in. That's why all of these can be positive to begin with. This will give me 4 times 6. Negative 1 squared is positive 1, so that will then be positive 24x squared. Here we will have 4 times 2, negative 1 to the third is negative 1, so that will then give me minus negative 8x. And then negative 1 to the fourth power is positive 1, and this is your final answer. All right, so for these, it's page 10, and it's factorized. So I'm just going to go through these very quickly. For A, we have an x. There's nothing else. So our GCF, remember, that's what we always look for first. So that would then be 2x. I'm sorry. They each are even, so we can factor out a 2x. So that would then be leaving us with x plus 2. For B, there's no GCF, so we're going to go ahead and draw our x. So there's a 1 in front of the v squared. So 1 times 40 is 40. Numbers that multiply to 40 that add up to 14 are 10 and 4. And since the number in front of v squared is a 1, we're dividing by 1 here. So then our b will factorize to v plus 10 times v plus 4. For C, I'll write this in a different color now. So C, our number in front of our v squared is 7. So we will then need to multiply 7 times 8, which is 56. So numbers that multiply to 56 to add up to negative 18. So that will then give me negative 7 and negative 8, because 7 times 8 is 56. And whoops, never mind, that does not add up to negative 18. Sorry, the numbers that actually add up to that, it was not 7 and 8, but it's 14 and 4. So it will then be negative 4 and negative 14. Remember, we need to divide each number side by the number in front of the v squared. So that will be 7 in this case. This reduces to negative 2 over 1. So we started from the bottom. So it's 7, not x, but 7v minus 4. And then the next one will be v minus 2. Then the next one that we'll do is d. So d, remember the number in front of the x squared is something other than 1, so we need to make sure we multiply that. So 5 times 20 is 100. So numbers that multiply to 100 and add to 29, well, that's 25 and 4. We need to divide each side by 5. 25 over 5 reduces to 5 over 1. So we started from the bottom, so then it's x plus 5. And now we're here, so we started from the bottom, so it's 5x plus 4. Our next one that we have is e. For e, we would look to see if there's any GCF. And remember, we need this x squared to be positive, so we know we're at least taking out a negative. And all of these are divisible by 3, so we know we're taking out a 3. So when we take out a negative 3, we're left with 4x squared plus 23x minus 6. And then we will go ahead and have to factor this. So we'll draw our x. 4 times negative 6 is minus 24. So numbers that multiply to 24 to have a difference of 23 are 24 and 1. And since this is positive, 24 is positive, we divide each one by 4. Well, this reduces to 6 over 1. So then it will be x plus 6 times 4x minus 1. And then our last one that we have is f. This one, anytime that we have a binomial with an x squared, and especially we look to see, is it a difference? So can we subtract it? We can. Can we take the square root, x and 1? We can. So that is a difference of 2 squares, so it factors to x plus 1 times x minus 1. All right, I know I went through those quickly, so if you have any questions, just reach out. All right, so this is our last page, which is page 11. So it will say solve by taking the square root. So we will first need to isolate our x squared. So we will get 4x squared is equal to 16. Then we will need to divide each side by 4. So x squared is equal to 4. And now once we isolate it, we take the square root. So we take the square root of each side. This is where a lot of you guys forgot. X is equal to plus or minus 2. This is now equal to plus or minus 2 because it was an equation and it was presented in a way what number squared is equal to 4. And since we know if we square a positive or a negative, it is still equal to a positive number. So this is equal to plus or minus 2. All right, the next question will say solve by factoring. Well, when we factor, we need to set it equal to, sorry, not x, we need to set it equal to 0. And we need our x squared to be positive. So that means I'm subtracting over 13x and subtracting over 6. A lot of you guys wanted to try and complete the square on your test. It needs to be set equal to 0. So it's 5x squared minus 13x minus 6 is equal to 0. Then we factor, or 5 times negative 6 is negative 30. Our negative 13 gets written here. Numbers that multiply to negative 30 have a difference of 13, or 15 and 2. And since this is negative, 15 is negative. Then we need to divide by the number in front of the x squared. So a lot of you guys forgot to do that on your test. So it'll be negative 3 over 1. So this factors to x minus 3 times 5x plus 2. And now, if two numbers multiply and equal to 0, that means one of the factors has to be 0. So x minus 3 is equal to 0, or 5x plus 2 is equal to 0. So then we would add over 3. So that means one of our solutions is x is equal to 3. Then we'll solve for x in this case, so 5x is equal to negative 2. We'll divide each side by 5, so or x is equal to negative 2 over 5. And then the very last question that we're going to do is this one here. Let me just move this up. This one will be solved by completing the square. So when we are completing the square, the difference for this is that we need to go ahead and set it equal to its constant. So this one is equal to its constant, or equal to the only number value. So it's not 0 like it is for factoring. So we'll add this over. So then we get 2x squared plus 4x is equal to 1. Now we say, is there a number in front of the x squared? Which there is. Now we factor out that a. So when we factor out the a, we're left with x squared plus 2x is equal to 1. Then we will divide each side by 2. So now we get x squared plus 2x is equal to 1/2. All right, now we can go ahead and complete the square. So we take the number in front of the x squared, so that's 2. We divide it by 2, and then we square it. And then we add that to both sides. Some of you guys were subtracting it. Well, 1/2 plus 1, we need to get common denominators, so we multiply it by 2 over 2. So 1/2 plus 2/2, or 2 over 2 is equal to 3 over 2. So that means now we factor this. So it factors to x, whatever number we got when we divide it by 2, and whatever sign we have here is always a sign in our factored form. So x plus 1 squared is equal to 3 over 2. We will then take the square root of each side. So now we will get x plus 1 is equal to plus or minus the square root of 3/2. Remember, after this semester exam, you will need to do this differently. But because of our time constraint when we came back from winter break, because I was absent, amongst other things, we didn't have time to necessarily show you the proper way of doing this. So for right now, I'm just concerned if you can get to this part, and then in the future, you will have to do it the right way or write it in the correct form. So we subtract 1, so x is then equal to negative 1 plus or minus the square root of 3 over 2. All right, for now, that will be your final answer. Once we get that from semester break, that will change. All right, that is it for this video. If you have any other questions, please reach out.